some of the earliest thinkings about computers were, how do I represent what happens inside the human brain? And the human brain is, I think as Scott was saying, one of the most complicated thing we've ever looked at. And trying to say, how do we model the brain has turned into the field of artificial intelligence. And within artificial intelligence, I've focused on machine learning, which is trying to come up with a model when someone says, here is a set of things I want you to learn, here's a set of things I want you to avoid. What is the connection behind them, behind those classifications? You might have mushrooms. Some of those mushrooms are edible, some of them are poisonous. And if you look at a mushroom and say there's like 7 interesting things about a mushroom, then you want to figure out a model that lets you look at those 7 things and then predict if it's going to be poisonous or not. There's easy ways to do that, to try to come up with a simple linear system that lets you separate out poisonous mushrooms from non-poisonous mushrooms. But most things you want to learn can't be divided up by a nice linear system. Early attempts in computer science and artificial intelligence tried to use what was called a perceptron, a simple weighted model where you could have input of some numbers, multiply it together with some weights, and then you get one number out at the end. It works really well for simple systems, but if you're trying to learn something very complicated, then just taking numbers and multiplying and weighting them isn't enough to really separate out the pieces. So perceptrons turned into, well, if this one thing doesn't do it, maybe I can put a lot of them together. Try to do that agent-based idea of throwing a lot of things together. And that lets you separate things with spaces that are curved, that are nonlinear in terms of what you're trying to separate. And that turned into neural networks and multi-layer perceptrons. Those are now turning into deep learning convolutional networks that you'll start to hear about in the news, where because Google and Apple and large software development companies have tons and tons of processing power and tons of information, they can start to set up neural networks that feed into other neural networks, which feed into other neural networks, and try to approximate the way that information might go into your eye, which then gets processed by some other piece of your brain, which gets processed elsewhere. And there's all these different small to medium to large representations that start to happen. And the more and more things you put together, the more flexibility your model has to find the right way to represent the world to be able to approximate what you want at the end.